show that the function f of xy equal to 3x minus 4y squared is differentiable at the point -1, 2. We know, by definition, that f of xy for any function is equal to f of x naught, y naught plus fx evaluated at x naught, y naught multiplied by parentheses x minus x naught, close parentheses, plus fy evaluated at x naught, y naught, multiplied by open parentheses y minus y naught, close parentheses, plus e of xy, where e of xy is our error polynomial, as it were. So we know that this is true. What we need to show, to prove that this is differentiable, is that e of xy divided by the square root of our x minus -1 squared plus y minus 2, or y naught, squared, the square root of that big quantity, that ratio goes to 0. So what we are going to do is find the error polynomial. So we know what f of xy is, and from that we can find f of -1, 2. Evaluating that, we get -19. And we can also find from this information fx is equal to 3, and fy is equal to -8y. So fx evaluated at the point -1, 2 is just 3. -1, 2, that equals 3. And fy evaluated at the point -1, 2 is equal to -16. Those are values we need. Now, this means that our function f of xy, which is 3x minus 4y squared, is equal to -19 plus 3, open parentheses, x plus 1, close parentheses, minus 16, open parentheses, y minus 2, close parentheses, plus e of x, y, solving for e of xy, rearranging terms, we see that it is equal to -4y squared plus 16y minus 16. Having developed this, we want to see, or show rather, that the limit as xy approaches the point -1, 2 of e of xy, that would be -4y squared plus 16y minus 16, that is our numerator, over the denominator, square root x plus y in parentheses squared plus open parentheses y minus 2, close parentheses squared. The square root of all of that, that sum, that is equal to 0. Well, this is going to be equal to the limit as xy approaches the point -1, 2 of -4, open parentheses, y minus 2, close parentheses squared, over the square root of the quantity, parentheses, x plus 1, close parentheses squared, plus open parentheses, y minus 2, close parentheses squared, which is less than or equal to, and take some time to convince yourself of this part, less than or equal to -4 in my numerator, -4, open parentheses again, x plus 1, close parentheses squared, plus open parentheses, y minus 2, close parentheses squared, close parentheses, over a denominator of square root of the quantity open parentheses x plus 1 close parentheses squared plus open parentheses y minus 2 close parentheses squared, square root of all that. And we can reduce this. Oh, I left off something important. I said this is less than or equal to that. It's less than or equal to the limit as xy approaches the point negative 1, 2. That is equal to the limit as xy approaches the point negative 1, 2 of negative 4 square root of the quantity open parentheses x plus 1 close parentheses squared plus open parentheses y minus 2 close parentheses squared. And that limit is equal to 0, which shows that the function f of xy is differentiable at that point, negative 1, 2.